So let's talk about using Euclidean distance and reclassify in place of buffer. It's a real easy way to get vector data and raster data and then apply values to it. And let's use bats. So bats is kind of an interesting species data set you got. You got a pretty nice table here with bats, right? Evidence, um, unknown, no evidence, no good. And then some specific bat species. You got these buffer distances here that you have to accommodate. Excuse me. And then you've got some planning values already set for you. So I built a model here that uses Euclidean distance and reclassify to do it, but I've left one of the bats undone here. So let's finish it off. So here I've got the Mitos bat. And look up, or it's actually an abbreviation for Myotis. If you look up Myotis bat species, you can see a picture of this cute little guy. As a range all the way down into Mexico. So what I did is I dragged the Euclidean distance tool in. I'm going to connect the bat point to Euclidean distance. I'm going to call my my output distance from my Otis or whatever he's called. Excuse me. And then I'm going to reclassify that output distance. So I'll drop the reclassify tool in, connect my distance up to it, and open reclass. So you won't get any values in the reclass tool till you run that distance. So run the distance. Right, then open that reclass, and then when you hit classify, you'll see the distribution. Now I only want two breaks because I want basically inside the buffer and outside the buffer. So I'll just select two, click OK. It shows me the values here. Go back to my table. So for Mitos, it's 150 meters. So my first value is going to be 0 to 150 meters. And it gets a planning value of 9. Right, so I'll give it a 9. Yep. Messed up my input data there. I had my mouse in the wrong place. Let's try that again. Okay, classify, 2 breaks. Okay, 0 to 150. Make it a 9. 150 to, and I always make my number super high on the second number. I just want to make sure I get all the top end of the elevation values. And there's no species there, so I'm going to call that 1. And I'm going to call this reclass Mitos. Click OK. I'll do my auto layout, zoom to extent, and I'm just going to go ahead and run the rest of these. So now what I'm getting in the end is for each of these bad input points, for evidence, for no evidence, for Mitos, for Pluto, for the unknown, I'm getting a separate raster, and those rasters have the buffer and the value. So for instance, if I add, let's do the one we will add Mitos in here. Ooh, yes, and this again, I forgot my reminder in the beginning and it bit me. Model properties, environment, right? First thing you want to set is your output coordinate system. Second thing, raster analysis, is your cell size and your mask, and your processing extent. Right? Set those values in your model. So these bat data actually don't have any projection information. So I'm going to go ahead and select something with some projection information already associated with it. The extent is going to be my study area boundary, cell size. I'm using 30 meters. Mask is my extent. Apply, okay. So, I mean, what happened there is I didn't have my extent set and I didn't have my mask set, so it only gave me a raster for the area between the points rather than giving me one for my whole study area. So that would have blown up my whole analysis. And even I forget. The nice thing is you can just go in and fix it and add your environment settings. So now we're rerunning. Boom. So now you can see it's fixed. Right? If I turn all these layers off except this one, right? There's my little points. There's 2 caves with these Midas dudes. And then if I add in, here's the areas with evidence of bats, the caves. It's a smaller buffer, but again, areas away from the caves are 1, areas near the caves are 7. So I want to combine these things together, but really I want to get the maximum value out of each one. Where there's a 9, I want a 9. Where there's a 7, I want a 7. Whatever the highest value at that location, that's what I want. So you might remember we did some different kind of functions. One of those local functions was local cell statistics. So here's a tool called cell statistics. So I'm going to drag that in, and I'm going to put all my different bat rasters in here with their different values. Alright, so they're all going into my statistics, and then I pick my statistical method. I want the maximum of all these values. Okay, and I'm going to call this, I'm going to put it in my results database, bat habitat potential. Okay, off it runs. Alright, oh, remember, save your model before you run. Model builder crashes, you don't want to lose your edits. Cool. Okay. I'll go ahead and add that to display. Bat habitat potential. Okay, let's again fix our color scheme. Make it something a little bit nicer. There we go. So caves with unique species get a 9 importance. Lesser caves get less importance. Down to the background data, which is the whole study area. Right. If there's no cave, then you get a 1. So you might also use this method for something like the carbonate species or any species. So you might give each species a planning value based on your belief of its importance, right? And then use cell statistics to combine them all together to get a maximum value. That's probably the easiest way to do a habitat conservation map. So yeah, enjoy.